Hello. Hi. We'll start in a couple of minutes. We'll wait for some time, then we'll start.
Come on.
Okay. So I'll share my screen now. I hope it is visible. Am I audible? Is someone ping in the chat?
Yes, yes, you are audible, sir.
So okay. So I think it's an extra session to clarify some of the final doubts, and I'll try to solve some of the questions that might help you solving your exam questions. So let's turn off the video. Thank you. First, we'll solve some questions from transport layer. What? Sorry. Sorry for interruptions. There is a bit of a, yep. So the first thing that we'll be solving today is a question from transport layer. So in the transport layer, first thing that we the transport layer, it is flow control. Okay. So in flow control, we have read three algorithms: stop and wait, selective repeat, and go back in. Okay. So we are starting the question. I'll just okay. Uh, okay. So Pranay is asking, sir, can you let me know if the exam format and if I do assignments or exam preparation, then it's enough to good score good marks, as I have external exam on Saturday and I have it was 70 km to appear in exam on NPTEL. I think you can mail NPTEL people for that, because I don't handle the exam things. I just handle the live tutorials and solving of problems. And you you can like ask you can ask the NPTEL people to answer the question. You can just send a mail and you'll be able to get your answer. Okay. So stop and wait. Uh, so stop and wait is there is a sender, there's a receiver. The sender sends the packet and waits for some time. Like this, it starts a timeout timer. So and if the receiver responds it within time, so this is the data and this is the acknowledgement. And if the receiver receives the data and send the acknowledgement, the sender send another data 2, let's say it's in the data 1, and we receive the acknowledgement 1, acknowledgement 2. That's it. It's a stop and wait protocol. So it will only send the data once it receives the acknowledgement.
ಇಲ್ಲಿ
Uh,
ಇರ್ತಾವ
Sorry. Sorry. I didn't realize I was in mute. Sorry. Yeah. So this is the stop and wait protocol, and stop and wait protocol. Uh, we have sender and receiver. Sender is sending data and receiving the acknowledgement, and sending the next data and receiving the acknowledgement. TOT is timeout timer. That timer that goes off. If the timer goes off, have the acknowledgement. So let's say in one scenario, let's say the sender sent the data and did not receive any acknowledgement. So it will send the data again. So how much time should it wait before sending the data again? It should wait time. Okay, and it should and if this is again lost, it will again wait for time and send the
मेरे
data.
भाई थके
Okay, so let's solve a question regarding this. The question says let's say I'm using stop and wait protocol to send data from sender to receiver, and let's say I want to send 10 packets. Okay, so I want to send 10 packets, and let's say every fifth packet is lost. Okay, so let's say every fifth packet is lost, and every fifth packet is lost. So so the question is, how many total number of packet would be retransmit will be retransmitted to transfer all the 10 packets. So the question says like you're sending 10 packets and every fifth packet out of this 10 packet is lost. Then how many packets are need to be transmitted in total? So you think for the answer for 2 minutes. I'll get back to you with the answer. Oh, sorry. Please repeat, sir. Okay, so the question is, you are using stop and wait protocol to send 10 packets, and every fifth packet out of this 10 packet is lost. So while you are retransmitting or sending, every fifth packet is lost. So the question is, how many packet in total would be retransmitted from source to the destination? So I'll solve the first question, so you can get it, so that you will get an idea. So we're sending 10 packets. So first packet will go as it. Sorry. So first packet will go as it is. Then we go second packet, third packet, fourth packet, fifth packet, and the fifth packet will be lost. Okay. So this sender will wait for some time till it receives the acknowledgement for the fifth packet, because as long as we don't have the acknowledgement for any packet, we cannot send the next packet. So It will wait for the acknowledgement. Or Gaurav Malik, all packet will reach. No, yeah, we know all packet will reach, but the question is how many packets need to be transmitted in total to make this 10 packets go. So yeah, so the fifth packet will be lost. So we have to retransmit the fifth packet again. We'll retransmit the fifth packet again. Then we'll go on and retransmit sixth, seventh, eighth, ninth, and 10th. And since 10 is another fifth packet, like every fifth packet is lost. So it is every fifth packet is lost. So this is 1, 2, 3, 4, 5. So yeah, 9 is the next fifth packet. So 9 will be lost and 9 will be transmitted again. Nine will be transmitted again. Then we will transmit 10. If you count, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total there will be that implies 12. Total 12 transmissions are needed. Perfect. Someone replied 12. Okay. So let's solve the similar question. Where like instead of fifth, let's say every fourth packet is lost. So let's try to find out uh, number for that. So 10 packets. Every fourth packet is lost. So what will be the answer now? So the trick is that you have to remember there is one packet uh, that is one packet that is going and like one packet that is going and it is waiting for the acknowledgement and uh, then if it is lost it will be returned to that. I'm getting the answer 13. I guess yeah, so 13 is the correct answer. Let's just solve for a bit. Yeah, 13. Everyone is answering good. I don't know where were you guys for the last 12 weeks. So no one was answering much. Anyway, so we'll solve this one. So every fourth is lost. So you draw one. So you draw one, two, three, four. Fourth is lost. You transmit four again. Five, six, seven. You lost seven again. Seven, eight, nine, 10. 10 is lost. You send 10 again. And total equals to certainly translation. Okay. So let's level up the question now and say, let's say it is sender to receiver and there is and there are 10 packets. And every fifth packet is lost, and you are using go back 3. Instead of go back n, so the go back n, the n is 3, is go back 3. That means window size equals to 3. So if window size is equal to 3, then total how many packets would be retransmitted? So total how many packets we need to transmit in go back n, go back 3. 30? No, I don't think there should be so much number. It's saying fifth packet, not fourth packet. You can check that. It's saying fifth packet. Twenty. At least I'm getting answers. That's impressive. 12? No, not 12, I guess. I'll get more than 12. It's go back n. It's go back 3. Okay. So I'll just tell what is go back 3. So when go back 3, if you have, we'll see the answer. So if you have we are sending packets, let's say one packet is lost in between. So you don't resend the packet as directly. You just wait for the window to complete, like all 3 complete. Then at this point, you go back and resend all these things. You resend all these things again. So let's just try to do that here. Send packet node 1, 2, 3, 4, 5. So fifth packet is lost. Okay. Fifth is lost, but you will not know now because you have to wait for the window to complete. So window size is 3. So you wait for 6 and 7 to complete. Now you realize, okay, fifth is lost and my window is going to move forward because the window moves it is 1, 2, 3, 4. Window moves like this and so on. Okay. Move forward. So I have to retransmit again. So you retransmit 5, 6, 7. Okay. Now 7 here is now 7 here is now 7 here is the fifth packet. So it will again be lost. Okay. But you will not know. So you'll 8, 9. So you'll keep sending 8 and 9. So once you reach 9, once you complete the window, once you complete the window, you have to resend it all these things again, like you have to send 7, 8, 9. And 9 is the fifth window. 9 is the fifth packet. It gets lost. And you have to send 10. Now the window is not complete because it is go back 3. Now it is just 2 packets. Since the number of packets have done, so window is complete. Okay. So now you have to retransmit 9 and 10. Okay. This is total number of transactions. If you count it, it's 4, 4, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The answer would be 18 rate transactions. Not retransmission, I would say 18 transmission. Okay. It's rolling back after every fifth packet and reach 10th packet, 6 into 5 is packet. No, Gaurav, like, I mean, you are like rolling back after it's not every fifth packet. So after fifth packet, it will wait for the window to complete. It will replay those things again and move on. So the window size is 3. So it will only replay 3. So it will not replay everything. So according to you, it should replay all the 6. What is 6? Yeah, it uses not communal acknowledgement. It's called cumulative. Yeah, cumulative. Sorry, cumulative acknowledgement. I read it as communal. No worries. It uses cumulative acknowledgement. And yeah, so we'll solve the last question. I understood. Okay. So we'll solve the last question in this quickly in this format. Last question is sender to receiver 10 packets. And every fifth is lost. And we're using selective repeat. That means window size in is 3. And we are using selective repeat and we're setting the window size to be 3. So can you calculate how many retransmission are needed here? I'm getting 12 from Akshit. Has anyone else has any answer? Please respond. Thirteen. It is fifth packet. 10th. Fifth is lost and 10 packets are sent and window size is 3. Okay. So I'll solve it. In selective repeat, what you do is that the same as go back in. So sender receiver. The sending packets. This packet is lost. You will not know what till the window is complete. So window it was, let's say, 1, 2, 3. Window is complete, but you will selectively repeat this. Unlike go back in, you don't have to repeat everything. So you selectively repeat this, and then you go on with your next packet. Okay, that's a selective repeat. Okay. So if we do that here, so first packet, second packet, third, fourth, fifth. Fifth is lost. Will not know. Sixth, seventh. Yeah, yeah. So sixth, seventh will selectively repeat 5. Then we'll go on with 8 and 9. And 9 is the fifth packet. Lost again. Then 10. and we selectively repeat 9 because the window is complete. 9. Okay, got it. So total would be 8, 9, 10, 11, 12. So the point where you are missing, you'll not know until the window is complete. So you let the window to be complete, then you selectively pull that thing out and repeat it. Okay. So everyone got the idea? I hope they do. So total number of retranslation is not retranslation. Okay. Second window completed 6 packet. No, window completed at 6 packet. No, the fifth packet is lost. Second fifth packet is 9. The window was supposed to go for light level for 3, but it completed at 10 because 10 is the second, like 10 is the last packet. So there is no other number to complete. So 10 packet is sent. So window will slide. There is no number to slide the window. That's the end packet. So we'll stop there and retransmit the ninth packet again. Okay. So we'll move on to some IP layer problem. So in IP layer, as you know that we have this IP address thingy, right? So we have two types of IP addressing. One is classful and another is classless. Classless is often called the CIDR notation or the classless interdomain representation. So in classful representation, we have assigned class. So class A will start with 1, class B will start with 10, class C will start with 110, and so on. And in class A, first 8-bit is network, and then rest 24-bit is host. In class B, first 16 is network, next 16 is host. In class C, first 24 is network, next 8 is host. But in classless, what I can do is that in classless, we can assign numbers like 192.1.1.1 slash 24 or slash 26. Okay. So slash 21 slash 26. Okay, so let's say if you okay, so let's say if you so if you're given like this, that means the first 26 bit is network, next 6 bit is host. Okay. So let's say if this is the IP address, question that I can ask is how many hosts are there, and second is how many usable hosts are there. Okay. Question 2 can be IP range. Okay. What is the IP range of this thing? Question 3 can be if I subnet this into two networks, how many hosts usable in each subnet? Question 4, network address of second subnet. So we'll solve this 4 question. I think today's extra session is just 1 hour. So we'll solve this 4 question and we'll call it a night today. Okay. So I'll wait for 5 minutes for everyone to answer and like just try. Then I'll start discussing in 5 minutes for each question and we'll be done. Sixty-four, 62. Then is 3P. Okay. So we'll solve it without wasting more time. So when you are given an IP address, the IP address is 32 bit. Okay. So when I say some IP address slash X, that means this is the network ID. Okay. So that means this is a network ID. So since this is a network ID, what I'll do is that, so what is the number of bits for host? So host bits would be 32 minus x. Okay. Host bits should be 32 minus x. 32 minus x. So when host bits is 32 minus x, that means here the host number of host bits would be 32 minus 26. That's equal to 6. So if I have 6 bits, how many number can I represent with 6 bits? So let's say, like, if I have 1 bit, I can represent 1 bit, like I can represent 2 things, 1 and 0. If I have 2 bits, I can place 1, 0, 0, 0, 1, 1, 0, 1, 1. That is 2 to the power n, which is equal to 2 to the power 2 equals to 4. Okay. So if I have 6 bits for host, I'll be able to create 2 to the power 6 host. That is equal to 64 host. That is equal to 64 host. Okay. So that is the answer to the first question. Then the question is, what is the usable number of hosts? Okay, so what is the usable number of hosts? So usable number of hosts is the, how I say, so the first ID in the network is used for network ID,
16
and the last is used for broadcast address. So the number of usable hosts, that implies number of usable equals to 2 to the power n minus 2. That implies 2 to the 6 minus 2, that equal to 62. Answer is correct. Okay. Okay. So the next question, question number 2. Question number 2 is, what is the range of the IP? Okay. What is the IP range? So when we think about IP range, what you do is that, so you must expand it. So 192.1.1. So you expand the last 8 digit, because why? Because we have 26 bits. So in a net, so if I give an IP address, and you are asked towards the range of the IP address, so you don't change the network address, you only change the host. So the last one is 1, right? So it can be written 0 0 0 0 0 0 0 0 1. Okay, and slash 26. That means first 26 bit. So this is 8 8 8 24 to 26. First 26 bit is network, and last 6 bit is host. So to count the range, or give the, not count, like, for counting we just did 2 to the 6 minus 2. But to find the range, what you do is that you fix the network side, like 192.1.1.0.0. You fix this. Then we put all 0 in front of, like, in the host. So 1, 2, 3, 4, 5, 6. Okay. That's the first IP address. IP of range. Also the network ID. Okay. When you put all 1, is the last IP address. So you put 1, you take 192.1.1.00 is all fixed. Then you put all 1, 1, 2, 3, 4, 5, 6. This is the last IP of range. This is the broadcasting. Okay. Okay. So if I convert this to numbers, so it will come as 192.1.1.0, and this will come as 1.1 dot. This is 63. 63. But this is the first and the last IP address. But if you see how many, okay, what is the IP range? So this is the IP range. Okay. Next question is, if I subnet this into two networks, how many usable in each subnet? How many usable host in the each subnet? So question number 3, subnetting. Okay. Subnetting is, so when you subnet, um, okay, you put range. So this is the usable range. Yeah, this is the usable range, but the first one is the IP range. So in subnetting, what we do is that in subnetting, like we divide, so we have a network, we divide it into two parts. Okay. So when you divide it into two parts, you need to identify these two parts as well. So subnet 1 and subnet 2. So to identify these two parts, we need ID. So for ID, we need bits. So if I have to identify two of the subnets, how many I to need to if I have to identify two subnets, so there is two ID. For two ID, I need one bit. Okay, so I need to assign one bit for subnetting, and rest would be as it is. Okay, so let's see. So 192.1.1.0000001. This is my original IP. So this is my network. I cannot toss this. Okay, and the rest is my host. This is my host. Okay. What I'll do is that since the number of hosts will be now reduced, I have to assign some to the network subnet ID. What I'll do is that I'll assign this bit, the lowest bit, as the subnet ID. Okay. This one bit, if I put it 0, that means subnet 1. If I put it 1, that means subnet 2. Okay. So if I try to find, so if I assign this, and if I assign this, and if I move ahead for host, now I have 5 bits. Okay. So if I have 5 bits now, how many hosts that I will have in each subnet? So for 5 bits, the number of usable hosts, I wrote it the number of how many usable hosts in each subnet. So if there is 5 bits, the number of usable hosts is 2 to the power n minus 2, that is 2 to the power 5 minus 2, that is equals to, that implies 32 minus 2 equals to 30. Number of usable hosts is 30. Perfect. So there is network, there is host. One is network ID. Sorry, you have the host, you have to divide it into two subnets. You assign one ID for source ID. You put this as source ID, subnet ID, subnet ID. So subnet ID, and rest is your host. Okay, and now you have number of the bits per host, and you can calculate the usable host. Then it is saying, what is the network address of second subnet? Okay, so we know the network address of a network is the first address. Similarly, the network address of a subnet would be the first address in the subnet. So if I divide this into subnet, the addresses would be, so 4, 0, 1. So this is the IP address. So this is your network, and this is your first subnet. Okay, so it is 0. If I put 0, 0, network is always unchanged, and I put 1 here. 1 here, that means is the second subnet. Okay. Second subnet, and this the rest are the host. So if I put all 0 here, then it will be my network ID. Okay, so if I put 1, 0, if I put sorry, if I put all 0, enter 5. So it is my network ID. But similarly, what will be my broadcast ID? It will be 192.1.1.001, then all 1. This is 32, and this is 63. So similarly, if I have to find the network ID of first subnet, then I'll keep the ID as 0 because first subnet. So to 1.1.000, then put all 0. This is network ID. And for broadcast ID, I'll just keep the network ID as same, this subnet ID as same, then I put all 1. So that will be my subnet ID. Sorry, broadcast address. Broadcast address. Broadcast address. So yeah, so I think we have discussed enough, and I think that the time is also going to end, and it's pretty late here where I'm staying. So we will close this here. Thanks for joining in the great numbers in the last session. I don't know why, like, where are you guys in the past weeks? But it was a great session, and I had fun. Could you please tell us the important concept for exam? I wish, but I'll try to post it in the announcement and see. Um, but because I am not the one setting the exam papers and everything, so that I don't have any idea as well. So just read things in and around, solve some questions, and solve some fundamental questions that is asked. So then you'll be able to score good. If I see, so I haven't uploaded the week 12 video yet. So I'll try to cover because there was an emergency here, so I couldn't record the full length. So I'll try to include some questions, important questions in the week 12 video as well. If you go and watch week 12 video, like you'll be able to get more questions and solutions like this session. Okay. Next question is pass ho jayenge? I don't know. Sorry, I mean I don't know actually the. Also, we are not given the exam questions after the exam is done. So I think passing is easy. I'm not sure. I don't think it will be much more difficult. Okay. I think yeah. I think we can end the session here, and I'll upload this video to the YouTube. If you want to refer before your exams, you can refer. If you want more questions like this, you can refer to the week 12 video, which has not been uploaded yet, but I'll be updating soon by today, tomorrow, and you'll be able to get all these things clarified. Okay. See you guys. Bye bye. Sir, in video week 12, not included in syllabus. No. It is included. I don't know about the entire syllabus. It is included. Uh, um, what I said is that I haven't uploaded the tutorial video of Quick 12 because it was half recorded. So I'll be recording that and I'll be updating that soon. Okay. So when I'll be updating that, I will be including a bit of problem solving as well with the theories. So with the assignment questions, I'll solve these questions as well. Thank you. I'll close the chat now.